Hi students, in this section we can discuss about a problem of riveted joint. First of all, I can read the question and we can discuss how we can solve it. I can read it. If possible, please write in your notebook. A double riveted lap joint is made between 16 mm thick plates. The rivet diameter and pitch are 20 mm and 80 mm respectively. If the permissible stresses are 80 megapascal in tension, 60 megapascal in shear and 20 megapascal in crushing, find the minimum force per pitch which will rupture the joint. So in this question they are giving the rivet is a lap joint and it is a double riveted joint. So we can find that the number of rivets is 2 because it is double riveted. And the plate thickness they are given, that is 16 mm thick. We can denote it as T, small letter T as 16 mm. Then the rivet diameter is given, that is 20 mm, and also pitch is given. We can denote that pitch as P, small letter P, that is equal to 80 mm. Then they are given the tension sigma T. Sigma T is equal to 80 megapascal, and the shear, that is denoted as tau, that is equal to 60 megapascal, and crushing is given, that is 120 megapascal. We can write it as sigma C, that is equal to 120 megapascal. Then they are asking about what is the minimum force per pitch. We can denote it as P minimum. Find the value of P minimum. This value we have to find out. And using data book page number 80, equation number 5.6b. The tearing resistance PT is equal to P into P minus D into T into sigma T. Here the P is the pitch and D is the diameter of the rivet, T is the thickness of the plate, and sigma T is also given the stress and tension, that is equal to 80. Thus we can find the tearing resistance PT is equal to 76,800 Newton. Then next one we have to find the shearing resistance, that is PS. From page number 80, equation number 5.6d, the value of PS is equal to N1 plus 1.875 into N2 into pi by 4 d square into 2. It is for a lap joint. This question is for lap joint. So there is no N2, that is N2 is equal to 0. And T1 we can consider it as same as T. Then N1 is equal to N, that is equal to 2 because it is a double riveted. If we substitute these values in this equation, that is PS is equal to N1, that is we can write it as 2 plus 1.875 into N2, N2 is equal to 0, and pi d square by 4 into tau. The value is equal to 37,699 Newton. That is the shearing resistance. Then the last one, crushing resistance. How we can find the crushing resistance? In our data book page number 80, equation number 5.6e. What is that? PC is equal to N1 into T1 plus, it is not T1 Ti, plus NT into T into D into sigma C. Here the values are already given. Ti is the same as the thickness, that is equal to, take it as 16. And here the value of N2 is not given, or it is, for a lap joint it will be 0. If we substitute all other values, that is D into sigma C in this equation, we will get the value of PC is equal to 76,800 Newton. Now in our question they are asking about what is the minimum force per pitch. So according to tearing resistance, shearing resistance and crushing resistance, we will get the values as PT, PS and PC. Among that, which one is lesser? That is PS, that is shearing resistance. And that value is equal to 37,699. So according to this question we can conclude that the minimum force per pitch is for shearing resistance, that is equal to 37,699 699. So P minimum is equal to PS, that is equal to 37,699 Newton. Okay.